So you want to melt some metal, awesome. But before you can get to that, you need to build your charge. The goal here is to create a solid, dense, and electrically conductive starting point. This isn't just about filling the furnace, it's about setting the stage for a perfect melt. A poorly built charge can lead to all sorts of problems, like slow melting, energy waste, and even potential damage to your furnace lining. Every piece has its place and its purpose, and it all starts from the bottom up. We want to build a foundation that can take the heat and get the energy flowing right where we need it. Let's get down. The very first thing you put into that big, empty furnace bucket is your heaviest, densest material. I'm talking about steel scrap, big iron ingots, or even large return scrap. These are the heavyweights of your melt. Why do they go first? Two big reasons. First, they create a solid, stable base that won't shift around too much. Second, and this is the really cool part, they form a fantastic electrical pathway. When you fire up an induction furnace, you need that energy to couple efficiently with the metal. This dense bottom layer acts like a perfect antenna, soaking up the electromagnetic energy and getting the melting process started quickly and powerfully right at the floor of the furnace. This initial layer is your bedrock. It's the anchor for the entire operation. By placing these large, heavy pieces at the bottom, you also protect the furnace refractory, the special ceramic lining that contains all that molten fury. Dropping smaller, sharper pieces of scrap directly onto the bottom could chip or gouge the lining. And trust me, that's a repair you do not want to do. So, this heavy base serves as a protective cushion for all the material that will be loaded on top of it. It's a simple step, but it's absolutely critical. It's the first rule of good foundry practice: build a solid foundation. This heavy bottom layer ensures that as the furnace power comes on, the heat generation is immediate and concentrated at the base. This creates a pool of molten metal relatively quickly, which then helps to melt the rest of the charge from the bottom up. The care you take in this first step will pay dividends throughout the entire process, leading to a faster, cleaner, and more successful outcome. Once your solid foundation is in place, it's time to build the next level. This is where we introduce the medium-sized materials. I'm talking about slightly smaller of scrap, maybe some sheared plate, or smaller return scrap. They fill in the gaps between the larger pieces, increasing the overall density of the charge. This is important because air gaps are the enemy of an efficient melt. They act as insulators, slowing down the transfer of heat and energy. Now for a crucial ingredient, carbon. This is where you'll add the bulk of your carbon razor, which is essential for turning iron into steel with the right properties. Why in the middle? Well, it's a brilliant bit of workshop science. By sandwiching the carbon between the heavy base layer and the lighter materials that will go on top, you protect it. Carbon is light and can be easily blown away by furnace exhaust systems or simply float on top of the melt without ever mixing in properly. Placing it in the middle ensures it gets trapped and submerged into the molten pool as the charge collapses. This leads to much better carbon recovery, meaning more of it actually ends up in the metal where it belongs. This middle zone is also the perfect place to start adding some of your alloying elements if your recipe calls for them. Things like silicon or manganese can be strategically placed here. Just like the carbon, these materials are better off when they are physically held in place by the surrounding scrap. This prevents them from being lost to the slag or oxidizing on the surface before they have a chance to dissolve into the iron. As the heavy base melts below and the upper layers press down, this middle section becomes a hot, compressed environment perfect for dissolving and mixing these key ingredients. So, to recap this middle stage, we are building on our foundation with moderately sized scrap to increase density. We are strategically placing the majority of our carbon and some key alloys in this protected zone. This ensures they don't get lost and are forced into the molten bath as it forms. It's a methodical approach that guarantees these vital ingredients are effectively absorbed. You're not just hoping they mix in, you are physically ensuring they do. Every layer has a job, and the job of this middle layer is to be the chemical core of your future alloy. We've built our foundation and packed the core. The top layer of the charge is where we place our lightest and smallest materials. This includes things like metal turnings, shavings, and other small thin scrap pieces. Why on top? Because these materials have a very high surface area to volume ratio, which means they can oxidize or rust very quickly when heated. By placing them on top, they are the last to see the intense heat of the melt. they will be pushed down into the already forming molten bath below, which protects them from excessive oxidation. If you put them on the bottom, a lot of it would just turn into rust before it ever had a chance to melt. This top layer is also the designated spot for the rest of your additions. This includes any remaining carbon you need to add to trim the final chemistry, as well as the all-important slag remover. Slag remover, like limestone or fluorspar, are materials that help create a good slag. Slag is the layer of molten impurities that floats on top of the clean metal. A good fluid slag acts like a blanket, insulating the melt, protecting it from the atmosphere, and absorbing impurities like sulfur and phosphorus. By adding the slag remover on top, it melts and spreads evenly across the surface of the molten metal, right where it needs to be to do its job effectively. Putting these lightweight materials and powders on top is a matter of simple physics and good practice. If you were to put slag remover and fine carbon at the bottom of the charge, a significant portion could be lost. They could get trapped in crevices between the heavy scrap or simply get blown out by the furnace's dust collection system before the melt even begins. Placing them on top ensures they stay put. As the charge melts and collapses downwards, these materials are gently deposited onto the surface of the molten bath. This allows for a much more controlled and efficient reaction, ensuring the slag remover forms a proper slag and the final carbon additions are mixed in properly. Essentially, this top layer acts as the final seal on your carefully constructed charge. It's the capstone of your metal tower. It holds down the lighter materials, protects them from being lost, and positions the slag remover perfectly to begin their work as soon as a molten pool forms. This strategic placement is not just about convenience, it's about maximizing material recovery and ensuring the final product is as clean as possible. Every piece of the puzzle, from the heavy blocks at the bottom to the fine powders on top, has been placed with a clear purpose, all contributing to the final goal, a perfect, efficient, and high-quality melt. So, what's the big takeaway from all this? Why go to all the trouble of layering your charge like a master chef making a lasagna? The answer is simple: efficiency and quality. By building the charge methodically, you are engineering the melt for success from the very beginning. The dense, heavy base ensures a rapid and powerful start, getting a molten pool formed at the bottom of the furnace as quickly as possible. This is the engine of the whole process. A fast start means less time with the power on, which translates directly to energy savings. In a foundry, energy is money, so this is a huge deal. A well-constructed charge is a cost-effective charge. The benefits continue as the melt progresses. With the carbon and alloys tucked safely in the middle, you get far better recovery. This means you can use less of these expensive materials to hit your target chemistry because you're not losing half of it to the exhaust or watching it burn off on the surface. This predictability is the holy grail of metallurgy. It allows you to produce consistent, high-quality metal batch after batch. You're removing the guesswork and replacing it with a reliable, repeatable scientific process. This consistency is what customers pay for, and it's what builds a foundry's reputation for quality and reliability. Furthermore, this layering strategy leads to a cleaner final product. By placing the light scrap and fines on top, you minimize oxidation, which means fewer oxide impurities getting trapped in your metal. The top-loaded fluxes get to work right away, creating a fluid, active slag that is incredibly effective at scrubbing the molten metal clean of other undesirable elements. A good slag practice, enabled by proper charge layering, is fundamental to producing metal that is free from inclusions and defects. The result is a casting that is stronger, more durable, and easier to machine. It's a direct link between how you load the furnace and the quality of the thing you pull out of the mold. In the end, mastering the art of the solid charge is not just about following a set of rules. It's about understanding the physics and chemistry at play inside that furnace. It's about control. Every layer is a deliberate action designed to influence the outcome. From ensuring a fast, energy-efficient start to maximizing alloy recovery and promoting a clean melt, the way you build your charge has a profound impact on every aspect of the operation. It is one of the most fundamental skills in foundry work, and getting it right is the first and most important step toward pouring perfect metal every single time. It's not magic, it's just good science. Okay guys, don't forget to subscribe my channel and see you on next video.